Welcome to this introductory video showing how to execute the Fluxomics C13 trace workflow on a Phenomenal CRE. We have a freshly deployed Phenomenal CRE on Amazon AWS, which was created through our portal web application. We will access this Galaxy on that CRE by pressing the Galaxy button on the portal frame for that deployed CRE. Here is the Galaxy instance running on our CRE created on AWS. We are going to log in with the user and password set at deployment time. To retrieve that password, we go back to the portal and click on the More button. In the next page, we copy the email used on deployment and take it back to the Galaxy login box, where we paste it under username, email, address. We then go back to the portal and click on the copy button next to Galaxy admin password. We go back to the Galaxy login box and paste the password copied on the password field, then press login. We are now logged into the instance. To the left, we have the different tools from Phenomenal. Transfer tools to get data in or out the instance, Fluxomics, NMR, mass spectrometry, and some tools from our collaborators at workflow for metabolomics, and some post-processing tools. Now we will upload some data so that we can use the Fluxomics tools. You should have downloaded a zip file mentioned in the help pages with example data for the Fluxomics workflow. We will press the upload button on the upper left, and we will upload some data locally available on the computer. Press Choose Local File button at the bottom of the dialog. We select Exchange File, constraints.csv, SVML model, tracing model, and the raw data input in netcdf compressed. These files are provided by our partners at the University of Barcelona group of Professor Marta Cascante. Click on the Open button or the adequate alternative in your system dialog. Now we have all the files that we want to upload. We need to set up the file type for the zip file, as Galaxy will try to otherwise unzip it, and this needs to be done by the tools. Press the Start button to trigger all the uploads. You can see how files are being uploaded to the Phenomenal Galaxy instance running on AWS. We can press Close now at the bottom right of the dialog box. Now we have all the data in the history. Now I will run the workflow using these tools. Press on Workflow on the top menu of the Galaxy screen. Click on Fluxomics Stationary Workflow to display the drop-down menu. Press Edit to see the different tools and how they interact in the workflow. We can see how the workflow looks like here. The important bits here are RAMID, which evaluates the peaks of mass isotopomer distribution, making it ready for correction for natural isotope of occurrence. MIDCore, which corrects 13 carbon mass isotopomers spectra of metabolites for natural occurring isotopes and peaks overlapping. And finally, ISO2Flux, which takes the corrected carbon-13 label data produced by the previous parts of the pipeline, and using a tracing model and an SVML model for the network, performs metabolic flux analysis to find optimal fluxes inside the network given with the measured intake fluxes. The results are generated in two files, one for best fit of fluxes and best fit of labels. The first one corresponds to reaction fluxes and the second one to small molecule concentrations. We also get a constrained SVML model with the fluxes boundaries and confidence interval for the fluxes. Now we will pair the input data on the history with the inputs of the workflow. We go to the cog button on the upper right of the Galaxy window and press it to select Run. We start by setting the first input, named exchange file, to the first element in our history, which is to the right in green, which is named exchange_file.csv. The second input, zip.net_cdf, has already been automatically paired us by Galaxy. The third input, tracing model, has also been correctly assigned by Galaxy. The SVML model as well has been assigned correctly to the adequate input. These three inputs go directly to ISO2Flux, and these inputs go directly to Ramit. Now we press the Run Workflow button at the bottom of the screen. The execution of the workflow starts. We can see in the history files that are going to be generated by the process running in the background of our small cluster running on the AWS instance. So the first task, midcore, finishes some 3 minutes later. The first output file, the isotopolog file, can be seen there. You can see some of the logs produced during its generation. To view the actual data, press the I button inside the box of the output file, which reveals the CSV in Galaxy. This is the output of Ramit, which reads the netcdf files and extracts relevant isotopolog data. Now we are waiting for the files to be produced by midcore, and then by ISO2Flux. Now we can see that all tasks have finished and all the files have been generated, which marks the successful execution of the Fluxomics workflow in the current state. You might have noticed that the output SVML is not showing up in the history. This is because how the workflow was set up to hide it. The unfilled star asterisk next to the output shows that this particular output will be hidden. If we press again on Analyze Data on the top menu, we can go back to the history. Here we can show hidden files by pressing on Hidden at the top of the history. There we can see the SVML file with all the fluxes set as constraints, which we couldn't previously see. To have an idea of what are the fluxes fitted, we can click on the eye icon next to the best fit fluxes. There you can see each reaction by ID with the minimum and maximum fluxes for those reactions. Pressing on the eye icon next to the SVML file output, we can see the upper and lower bounds of fluxes for the reactions, this time annotated inside the SVML. Thank you for watching. This was the demo for the Fluxomics pipeline, generated in collaboration with the group of Professor Marta Cascante at the University of Barcelona in the context of the Phenomenal Age 2020 project.